Welcome everyone. Today I'll talk about implementing a custom voice AI uh, so you can create your own voice assistant. And we will do this by using WebRTC to stream voice from a browser microphone to a backend server. And the backend server will talk to certain Google technology and then return an answer. My name is Lee Boonstra. I'm a developer advocate at Google, and as a developer advocate, I'm responsible for conversational AI. So this means like chatbot technology, like Dialogflow, but it also means speech technology, speech APIs, speech to text, text to speech, and technology in contact centers. What is an AI voice assistant? Well, that's a piece of software that can run for an individual and then based on commands and questions and then return results through human voice by synthesizing the text to speech. Why would you create your own custom voice AI? Why wouldn't you use the Google Assistant or Siri or Alexa? This is not a talk about the Google Assistant, but you will hear me referring to it a couple of times because there are here some facts that you just want to be aware of. The Google Assistant, for example, is publicly available, and that is a great reason if you are a brand and you want to bring your brand to the larger crowd, because there are so many Google Assistant devices or Alexa devices. That's great if you can deploy your apps too. Maybe not. It runs across all Google Assistant devices. That means the Nest Hub. Previously it was known as the Google Home. But it can also run in Android phones and tablets. It can even run on iPhones through apps. And with the Google Assistant, you get like all these native features. For example, you can ask the Google Assistant certain questions and you get answers for. You can ask the Google Assistant to turn off the lights. If you have it connected to third-party hardware, then it will be like a smart IoT house. But you can also communicate with apps. And we call that in the Google Assistant ecosystem actions. It's part of the actions on Google framework. And to open such an app, you need to invoke it by using certain Google wake words, like, for example, hey Google, talk to my app. And then your app will be deployed on the Google Assistant ecosystem, and so are millions of other apps from other people. Maybe you don't care about all these other apps or all these native features. You just want to run your own app. Maybe you're an enterprise and the Google Assistant comes with consumer terms and conditions. Maybe that's not what you want. Besides that, the Google Assistant also has a set of specific technical requirements, such as that the microphone can only be open for an X amount of seconds. Maybe you want to keep the microphone open for a much longer time. So there are lots of reasons why you could build your own voice AI. And some of these use cases that could be like self-service kiosks. These are the machines that you see on airports and in train stations, for example, to order tickets from. And you can maybe use that by using your own voice. These can be devices with custom hardware. Maybe you are a developer and you have a Raspberry Pi and you want to do some fun stuff with your own voice commands. That could be. Car navigation systems. They use voice, spoken voice, and they return voice to you. It's also custom. It's not, you don't need to talk to Google first. Smartwatches, maybe a custom voice in websites to browse to certain pages without using actually your mouse or keyboard. And the last use case, these are in the contact centers where robots, for example, could pick up the phone and handle the whole conversation for you. And you can do that, for example, like when it's very busy in the contact center and you don't have the people to pick up all these phones because the waiting time and the hold times are so long. So you automate this by having robots picking up the phones, and they sound very human-like. These are all reasons where you could use custom voice AIs for. There is a big difference between the way how the Google Assistant works versus creating your own voice AI. And that is that the Google Assistant mostly works with short utterances. So that means like you will say a simple sentence. I can say like, hey Google, turn off the lights. Okay, then the AI can quickly understand what the intent is, because the intent here is to turn off lights. But when you have a custom AI, for example, in a contact center, yeah, people can start with whole books of stories. Like yesterday, I forgot to pay my bill, but then my husband said, like, well, you can wait a couple of days. The next day I was sick. Now I don't know what to do. Like, it's sometimes even difficult for a human, yeah, to figure out like what is the intent, what question do I need to answer. Now imagine how that is for a machine. Like there are so many sentences being said. What's the sentence that I need to answer on and return? So that means like these are long utterances. It keeps polling for incoming voice and returns the voice. Now, for my app demo, I'm using a set of tools. I'm using the browser's microphone, and I'll use WebRTC in this case, so I can capture an audio stream, and I'm sending this stream to a backend. And in the backend, I will use this audio stream to talk to certain Google APIs. And in my case, this will be speech APIs, from speech to text. Then I have written text. From there, I might want to translate it to a different language. And then I'm going to detect the intent with Dialogflow. And once I finally got the response, then I return it with text to speech. So I get back an audio buffer, and then I will play that back in the browser. So it's kind of tricky to do this, but I'll show you today how to. All right, let's have a look into my demo. This is a demo of a self-service kiosk, like a fake one, of course. And imagine that, you have an airport, and at the airport you can ask questions by using your voice. Actually, now in the Corona time, this is actually will be a great use case because people don't want to touch or like other like keyboards and so. Because other people are all touching it. So by using your voice, that will be a great use case. In this example, you can see I can start the application, and then I can start asking questions, and it will return some answers on the screen, such as what time is boarding?
Passport and security checks and boarding can take longer than expected. Per airport, these times may also vary. To prevent delays, we ask that you arrive at both the airport and the gate on time, especially during the busy holiday travel seasons.
Can I take a lighter in my hand baggage?
Small lighters and safety matches are only allowed if they are worn on your person, not as hand luggage. Carry them with you in your jacket or pocket.
Now, actually, I have another feature built in, and I could also use my own native language, and then it translates it back in my native language. So I'm going to set now the machine to Dutch. I can ask a similar question. Hoe laat moet ik bij de gate zijn?
Paspoort- en veiligheidscontroles en instappen kunnen langer duren dan verwacht. Ook per luchthaven kunnen deze tijden verschillen. Om vertragingen te voorkomen, vragen we je om op tijd op de luchthaven en bij de gate te arriveren, vooral tijdens de drukke vakantiereizen.
Now, and what's so special about this is like the Dutch version is not built into Dialogflow. It's just translated on the fly, and it sounds perfect Dutch to me. Now, so how did I build this? Like with all problems, once you face problems, if your problem isn't already on Stack Overflow, you're either a genius or a dumbass. And the problem that I had was like my problem wasn't on Stack Overflow, and I figured like, no, I'm not a dumbass. It's just like super difficult to do, build a flow like this, because you have your audio stream in the browser, and then you need to talk to technology that's all running on server side. And like with many problems, it's always the case. It's like It's not just talking to Dialogflow or talking to a speech API that's difficult, or setting up a stream in a browser. It's like the combination of all the tools all together. And that's what makes it difficult. But I found a solution, and I've created the best practice for this. And yeah, it starts by creating a front-end app. And in my case, as you've seen, it was an Angular app where the user records the voice with the browser microphone, and then eventually, after the results come back, it will return audio back into the browser app. The first problem that I faced was, how will the microphone work across all browsers? Because I figured out, like, oh, it works great on my Mac, and it didn't really work great on iOS devices, and also in Internet Explorer it had some quirks. So I needed to come up with a solution for that. Also, I had to make sure that the audio, the stream that will be like handled. How will that be treated in the backend? Like, I think on the front end it was an audio buffer, and I don't think Node.js, because that's what my server always looked like, couldn't handle that right away. So the first problem that I solved was actually by just using somebody else's great work. I found a library online which is called WebRTC. It's based on WebRTC, and it's just a library for audio and video and screen activity recording. It's open source, so that's great. And how that looked like is kind of like this. In my Angular app, I created a class, and in this class I am I'm loading the WebRTC library. So, like, first on start, so once you start the application, yeah, it runs navigator.getUserMedia. That's the method, the WebRTC HTML5 method that's built in your browser. But I'm using the WebRTC, and by using the WebRTC library, yeah, I could make sure that it works across all browsers the same way. Now, the tricky thing is you need to set this up, and so it's very important that when you set a sample rate, that the sample rate should be also the same once you code the server-side implementation. So my recorder type, I set that to stereo audio recorder, even though on the backend I only can handle mono audio streams. But the great thing about this library is, once you use a stereo audio recorder object, you can set the number of audio channels. So I could set it back to 1 again. That's what I did there. I need to set a time slice because I'm working with streams. What I'm doing here is actually I'm creating chunks of my stream, and those little chunks, that's what I'm sending to the backend. And I set it on 5 seconds. So that's just enough for filling in a simple sentence, and then it will continue by going on. I set the desired sample rate, I downsized it, just so that the stream, by sending the streams, those are nice and small, so my application performs faster. Right. Then, yeah, of course, I'm talking to my backend application. And yeah, the next question was like, well, how would I stream this from the front end to the backend? And how can I deal with bidirectional data? And what I did here was I was making use of Socket.io. Socket.io is actually in real-time bidirectional event-based communication, and I used an extra module on top of that, which is called Socket.io Stream, and that's great for binary stream transfers because, like, I could stream both ways. Yeah, so I can just install that on my Node application. So what I'm doing here is, as soon as the data is available, I am sending the binary stream. In my Angular app, it's in my service, so I'm sending this binary stream to the backend, which is what you can find here. Send the binary stream, and this is the Socket.io stream implementation where I stream this to the backend. I do give it a name. That's just so for I send some metadata, and a size, and then the target language. The target language is because, as you have seen in my demo, where I was switching the flags, yeah, it's nice to know like which flag was actually selected, so that will be the target language later on. Then, I mean, what I need to do is I have this stream, of course, and I need to take this stream and make text version out of it. And this is something I could do really great with the Google Speech to Text API. It takes audio streams or audio files and it converts it to text. This API recognizes over 120 different languages. So it even, I mean, I even don't need to set the base language. It recognizes it recognizes which language it is, and then it yeah, puts it into a text variant. Yeah, so here you can see the speech implementation in my Node.js code. Here I am, first I'm setting up a speech to text request. And now this is again important. I need to make sure that my sample rate is the same as the sample rate that I'm using in the front end. In my case, this one comes out of an environment file, but I made sure it's the same. Then I need to set the encoding. The encoding that I set that in the environment file as well. Let me just open it so I can show you what I've done. So you see here the sample rate is 16,000. Again, this was the downsized sample rate, right? So not the one from the browser, but the one that I downsized it to because the stream was smaller. And here is the encoding setting. This is a setting that that's based on the Speech API. If you go to the Speech API documentation, you can choose like from a bunch of options, and this is basically like a wave file. Yeah. So I create that object. I can say the microphone distance is near field because the microphone will be close to the screen, and I'm having enhanced, like advanced machine learning models that I'm using, and I'm enabling automatic punctuation so that it also can automatically makes ends of sentences for me. And then I can make the call. Now in my case it's not a simple speech to text call, it's a speech streaming to text call. So I take the stream that I received from the front end via socket.io stream. I know the language, and then I have a callback function which will be executed once it's done. And this is actually the magic. Here I say streaming recognize, and I pass in the speech request, and then as soon as data comes in, yeah, it returns the results. And this is just the text what's been said. And as you can recall from my demo, you saw this in the waveform. You saw the phrase that was being said, it's being captured. So then we have an architecture like this. Now we need to pass it to Dialogflow because we want to figure out what the intent is. Like we want to detect what actually is happening here. And Dialogflow, that's actually a development suite for building conversational UIs. So people usually build this for building chatbots. It was formerly known as API.ai, but got acquired by Google in 2016. And now there's like a whole Google Cloud team working on it. And the way how Dialogflow works is based on machine learning. So it does natural language understanding. We understand what's being said, and we can match that to a certain intent classification. And the way how it works is in Dialogflow. This is what you see. This is Dialogflow. It's a UI interface, but as you will see later on, like also comes with an SDK. And in Dialogflow, it works based on intents. So I can create like a list of all different flows, like conversation parts. And such a conversation part needs to have training phrases because I'm training a model in this case. So when I have a question like what time is boarding, yeah, I could say like what time is boarding, what time should I board, at what time should I be at the gate? Like, these are all different ways of asking basically the same thing. And once a user says their utterance in the browser app, what Dialogflow will do is it will get the text. I mean, we have now the text version, as you've seen, and it will basically look in the model and figure out like which of all the intents is the right one, and that one will return the answer. And then the answer could be either in hard-coded in text. In my case, I'm returning also a custom payload because I want to show the question and the answer nicely on the screen. But let's say that I would connect it to a backend system, to a different database. Yeah, then I could enable fulfillment, and I say like, well, the answer actually comes out of a webhook. Dialogflow also works with entities. So these are like objects where you can take action on. For example, I created an object airlines, and then like these are all the key value pairs for airlines. So it's basically a variable. So if I would have an intent like what gate is KLM, then KLM is the variable part. It could be Flybe, or it could be Corendon Airlines or EasyJet. Doesn't matter. Like we capture the parameter and figure it out. And we can even work with synonyms if we want to. Like we can just specify them here. Yeah. Now I did something else in my demo app. I also make use of knowledge bases. Actually, what I'm doing is just I'm importing like a certain airport FAQs from websites. So if I would go to the Dutch airport, they have an FAQ page, and I'm just loading all the questions and answers in. So now I could also ask one of these questions in my app, and yeah, it will return the answer. So that's really great. Now, what we will do is we have this text version, and we will send the text to Dialogflow to do the intent matching. And actually I did like some extra steps here, as you've seen in my last part of the demo, where I also use translate. Because like, as you have seen in Dialogflow, I only am storing the English version of all the answers and questions. But what if people speak Dutch or Chinese or German? Yeah, then they can just use their native language, and they will also hear German audio or Chinese audio, but Dialogflow detects it based on English language. So I'm gonna show you the implementations of these two. First, the translate. I'm setting up a translate. Again, this is on the Node.js backend. I created a class, translate, where I create a translation client. This is the Google Translate API. I am pointing to a Google Cloud project where the Translate API is enabled. And again, a Translate API can detect automatically the text, the base language of the text, although I could set it as well. And I'm setting the target lang. And again, as you can recall from my previous examples, I'm setting the target lang in the front end, and once you select the flag. And then the whole magic here is like on the translation client, you run .translate.text and you pass in the full request, and then it returns you a translated version of the text. Yeah. In my case, this means then, like, let's say I spoke Dutch, so it took the Dutch version of the text. Yeah, the text I have, I have the spoken text written out, and I'm passing it to translate it to back to English, and then I'm returning the English phrase. And the English phrase, this is what I pass into Dialogflow, because then Dialogflow can do the text. So if I open Dialogflow right now, the Node.js class for my Dialogflow implementation, it's here. I'm doing basically the same thing again, like I'm creating a class, I'm defining my project ID and the language code, and in my case this is English, and I'm setting up the Dialogflow agent. I need to create a session ID because every session, every conversation that I have with the agent should be unique. So I create a session client, and from the session client you need to create the session path, which basically contains the project idea to make sure like which agent in Dialogflow is it, and then the session idea to make it unique. And then I create the request where I say, like in my case, this is a query input based on text, and I'm using the language code that I'm using. And then the whole magic here is to run the detect intent. So on the request query input text, you specify the translated text. So in my case, the English text. And here I have like a promise where it says like on the session client, I run detect intent with my request as input, and then I get responses back. And the responses, yeah, in my case, as you can recall from my Dialogflow interface, I had like a custom payload where I get like the full object out. So I have the question and the answer, and I can return that. Then I do run it again back to the Translate API to translate it back to Dutch. And that's the part that eventually need to be spoken out. Here you see the architecture. And once I have the translated voice, so in my case Dutch, I need to speak it out. And I'm using the synthesizer for this. So I'm using Cloud's text-to-speech. Now, to synthesize the text, we will make use of WaveNet technology, and Google has an API for that as well, which is called the text-to-speech API. And this API makes the voices or the sound very human-like, and you can even control the pitch and the pace and the pauses if you want. And I am doing this again in my speech class. I wrote both. I can create first a text-to-speech object where I design a voice. I can say like it's maybe in my case I think it was a male voice, and I need to set the audio encoding again based on the options from the text-to-speech API. And again, like it's probably linear 16 because that's nice in the browser. I don't want to encode it because then I need to work with converters. I could if I want to keep it smaller, but I didn't do that. Yeah, then I'm sending it to the text-to-speech API, where I take the input text, and then here's the magic. I run synthesize speech with the input as a text, and then I get an audio object back, an audio buffer back. And now this audio object needs to be returned to the browser. That's again a tricky thing, because how will I be sure that it will play in every browser? I figured already that iOS was doing a buggy with that. That is because a user need to accept it via the user interface before you can play something, because they don't want on phones that you can just bomb people with audio. You need to, as a user, need to accept it first. So I did do some quirks there with resuming and pausing it. But I got it to work. And the thing was, I had to go back into my Angular app. And here what I did is I created, and this is again a native WebRTC from the HTML5, so in the browser. You create an audio context. And I did some other things here as well. I created like an analyzer and a visualizer to show also the waveform nicely on the screen. But the way how this basically works is you need to assign it to a source, and a source that could be your computer speakers. And you create a source, and then you pass in the stream that you get from the server, and then you connect to it. Yeah. And again, I need to do some quirks here by stop and starting it, resume and starting it, to make sure that it also works on iOS. All right, so first I had it running on localhost while I was developing it. And when you run it on localhost, I think the only thing you need to do is like you get like a pop-up in the browser where you need to accept and allow your browser to record the microphone and play audio. Well, when you want to run a solution like this in a cloud, you need to be sure that you run on HTTPS. So you need an SSL certificate. In my case, this was very easy because I was using Google Cloud, so I could make use of App Engine Flex. And App Engine Flex can automatically set up SSL certificates for you, free. And that's easy. So it's just a deploy command on the command line. And then it basically creates a container for you. And with that container, the container will be deployed. Now, if you think like, wow, this is really cool, I would like to play around with this myself. Yeah, you can do so because I open sourced my code. It's on GitHub. You can just clone the repository. If you have some suggestions, yeah, feel free to create some pull requests. I'm happy to browse through it and yeah, get your feedback. Thank you so much for watching this video today. Also, my slides and all materials in blog form are available from the GitHub repository. So enjoy.